Okay, good morning. Welcome to
FunMath number 123.
FunMath number 123. Today we're still in section 6.1 of Art of Problem Solving's Algebra book. And since we're taking a little field trip tomorrow, we'll be in section 6.1 tomorrow too. So I thought we'd just do kind of a problem that just talks about ratios here. So for a regular clock, so a clock with a minute hand that's working correctly and a clock with an hour hand that's working correctly, and not one of those weird clocks.
Like a binary clock.
Like, not yet, not a binary clock. For a regular clock, what is the ratio of the speed of the minute hand to the speed of the hour hand? Okay?
Yep.
Do you understand the problem?
Yep.
Alright, so how do you want to approach this?
Well, for a clock, this area for the minute hand, that's 5 minutes for the minute hand.
Okay.
For the hour hand, that's 1 hour.
Alright.
So, it takes the minute hand this is also 30 degrees.
Okay, it's also 30 degrees, you're right.
Takes the minute hand 5 minutes to travel 30 degrees.
Okay.
And it takes the hour hand 1 hour to travel 30 degrees.
Okay.
Minute hand 30 degrees, 5 minutes. And the hour hand, where should I write that?
Right below. The hour hand goes
30 degrees for an hour.
Okay.
So it goes 6 degrees per minute.
Well, you found two good speeds here, actually. So I'm asking you for the ratio of the speeds. You have one speed in 30 degrees per 5 minutes. The other one is, hour hand is 30 degrees in 1 hour. So how can you make a ratio out of this?
Well, fractions are fractions.
Okay, so show me. So the minute, the speed, all you're trying to do is find the ratio. So we're going to do the minute hand. I'm just going to write minute over hour. Hopefully that's not too confusing. How fast is the minute hand going?
It's going 6 degrees a minute, or 30 degrees in 5 minutes.
Well, you use what you wrote. You don't need to make it more complicated. So you're going 30 degrees in 5 minutes. Okay, so you have a good solution here. 30 degrees over 5 minutes. That's the speed of the minute hand, and now the hour hand is going 30 degrees divided by 1 hour. Okay, now this doesn't look like this doesn't look simplified, right?
Yeah.
But let's look and see what happens. Okay? So, sorry I have to erase, but what happens when you have a fraction divided by a fraction?
The bottom one just flips.
The bottom one flips upside down. So I get the top 30 degrees over 5 minutes times this one flips. 1 hour over 30 degrees. Now what cancels here?
These.
The 30 degrees and the 30 degrees cancel. Now it's weird to be canceling degrees, right? But they're the same thing. And we're left with 1 hour divided by 5 minutes as our ratio.
So
now how are we going to simplify that?
It's 1 hour and 5 minutes.
Okay, how are we going to simplify that? That's not 1 to 5. Okay, the units are different. 1 hour and 5 minutes. It's 1 hour to 5 minutes, but I want a number for this ratio. How are you going to simplify 1 hour over 5 minutes?
We need to get the units the same.
We need to get the units the same. Exactly right. 1 hour. 1 hour over 5 minutes.
Well,
how are you
an
going to
hour
simplify?
is 60 minutes.
Oh! Yes! An hour is
60 minutes.
this 1 hour over 5 minutes is 60 minutes over 5 minutes. Okay, so what is the ratio now?
It's 60 to 5, or simplified, it's 5 times 12 is 60. So it's 1 to 12. 12 to 1.
12 to 1. What is the ratio of the speed of the minute hand to the speed of the hour hand? 12 to 1. Okay, now let's see if that makes sense, because you thought about it exactly right. It was a little bit harder to organize the thoughts. In 1 hour, the minute hand goes all the way around the clock, right?
Yeah.
And the hour hand goes from, well, I started at 3 here, so that's fine. It goes from 3 to 4. Okay? In other words, it goes 1/12 of the way around. So this one thing goes all the way around, and the other thing goes 1/12 of the way around. In other words, the minute hand is moving 12 times as fast as the hour hand. Does that make sense?
Yeah.
Okay, which one's moving faster, the minute hand or the hour?
Hand.
How much faster is it moving? What?
It's moving 12 times.
It's
faster.
moving 12 times faster. So when the hour hand covers a distance that's 30 degrees, as you pointed out, or 5 minutes, as you pointed out, the minute hand goes all the way around once. So it goes 12 times as fast. So your solution was very, very good. You wrote down how many degrees it moved in a particular time versus how many degrees it moved in a particular time, and you calculated that ratio. And that ratio ended up being 12 to 1. Okay? All right, good job. Good job.